All right, what do we have? From a point A due south of a tower, the angle of elevation of the top of the tower is 23 degrees. So from a point A due south of a tower, so that's south, the angle of elevation to the top of the tower is 23. So draw it. Elevation is 23 degrees. From another point B, which has a bearing of 120 degrees from the tower, the angle of elevation of T is 32. Okay, so you definitely know this angle here, there, elevation, that's 32 degrees. We can all see that? Does that make sense?
Yeah.
Okay. The bearing has got to do with the ground. You guys got to understand that. Bearing's got to do with the ground, not in air. This is in air, of course. So your bearing, the idea of it is if this is south, this is north. One more time. This is south. This is north. This straight line is 180 degrees. And if this is at a bearing of 120, that means technically it looks something like this. See, there's north, bearing of 120. That's what it's trying to say. That's where B is. So technically east, if you guys want to know, east is somewhere there. That's the way you got to look at this. So bearings on the ground. Don't let that confuse you with your elevations. Elevations in the air, obviously, how far you've elevated up. The distance AB is 200. Anyone not understand the bearing concept? Because that's usually the trickiest bit. Or did this diagram make sense? Okay, because once you've got that 120, you understand that, then really this bit in here is 60 degrees. And I think we kind of know what to do. Hence find the height of the tower. Yeah, this is H. We know that. And then usually you'll find a relationship for OA in terms of H. Find a relationship OB in terms of H. Use this triangle down here. What are we going to use? What formula for down here? Cosine rule, cos rule, and fingers crossed, and it should work out. That's it. Nice and simple. So opposite over adjacent. Tan 23 equals H on OA. So therefore OA is equal to H on tan 23. And just so you guys know, in case it comes up, that's the same as saying H cot. So be aware of that. Don't think it's any harder. OB, tan 32. Tan 32 is equal to opposite over OB, H on OB. So therefore, again, OB is equal to H on tan 32. And cos rule. So 200 squared is equal to A squared plus B squared. A squared plus B squared minus 2AB. Oh, we're going to run out of room, aren't we? Times cos C. I'll leave. Has anyone actually found the answer for H? Then can we possibly continue from that line then? You off? See you. Okay. Did we get an answer yet? Come on, haven't you guys already practiced all this? How could you guys be leaving this minute? From here,
do we just factorize out?
Factorize h squared out. Then you have this big monster, which you would never write. And then you're going to divide it. Then you're going to square root it. It's all done on the calculator. Doesn't seem like you guys are used to it, which means to me, it doesn't look like you guys have studied it, because it's very simple. So all I'm going to do is plug everything else. 1 on 10, 23 squared, plus 1 on 10, 32 squared, minus 2 times 1 on 10, 23, 1 on 10, 32, cos 60, all in my calculator, and then divide it. So come on, you guys, start doing that. 1 on 10, 23, all squared. Plug it into your calculator. 1 on 10, 1 on 10, 23 all squared. Then plus 1 on 10, 32 squared, minus 2 times 1 on 10, 23, times 1 on 10, 32, times cos 60. I got 4.3. This should become 4.3. Then you'll divide it, 200 squared, divide by answer, square root, answer, 96 meters. See, all done in your calculator. I don't understand. I'm watching Novak and he was just trying to work it all out, but it's not meant to be done like that. You're meant to just factorize your h squared out, and then literally 1 on 10. Please, is anyone not able to get that? You shouldn't run away from it anymore. You can't. Just plug it into your calculator, everything except the h's, obviously. Exactly as you see it, you should see 4.3, divide it, square root it, divide, square root, you're done. Any questions? Move on or just wait? Move on? Everyone's okay with moving on? All right. Let's go with okay, let's start with 2010. B. That f of x equal to inverse cos of x on 2. What is the domain of f of x? What's the domain? Straight away?
And minus 2.
So minus 2 to 2. Everyone happy with that? Start D. Let me know if you've got any questions. Maybe start F. Three marks. X cannot equal to -2 is your first answer. Then we'll just multiply it across. And then divide 3/4. Take away 2 equals X, which means X equals -1.25, -5/4, something like that. Yeah. And then number line, -2 is there, -5/4 is there. They're both open circles. And then you would test X equals 0, 3 on 2. Is that less than 4? No. 3 on 2 is not. Sorry, 3 on 2 is less than 4. Yeah. So this would work, which means they run away. So the answer is X less than -2, X is greater than -5/4. Any questions? Start with F. Five ordinary, 5 6-sided dice are thrown. Corresponding exactly two of the dice, then showing a 4. Okay, that's an easy one. If you guys don't do it wrong. Exactly 2. So what's the probability of getting a 4? 1 on 6. What's the probability of not getting a 4? And you want only 2 of those out of the 5. You want to choose 2 out of 5 to be a 4. So pretty much any 5, you're going to choose 2. That's the amount of ways that you could do it. You can pick them. Times, you want 1 out of 6 times 1 out of 6, which is squared. And then you want the other 3 to fail, to get you not a 4. That's power of 3. So 5 choose 2, 1 6 squared times. Look, that looks like a binomial question, which it should be, because this is part of like binomial probability, which is probably more next year than it is this year, but still. 5 choose 2, success squared, failure cubed. Tricky one. But anyways, any questions? Makes sense when I do it, I know. Yeah. I know. You guys got to practice math, practice, a lot of practice. B, there you go, your favorite questions. Do it. Don't wait for me, start. Not done? Not yet. Okay. We'll get started in a sec. All right, here we go. Show the rate of growth of the mass of the whale is given by this differential equation. Just in other words, differentiate it and show that it works. So here we go, dm on dt. Bring the k down. Negative and negative makes it into a positive. So k, and then we have 35.5 e negative kt. The reason why I did it that this time, because I can see the answer. It says positive k, and then it says 36 takeaway m. Can you see if I did this guy, brought it over to this side, that gives me positive 35.5 t, and then you would bring the m to this side, and you will be left with 36 takeaway m. Exactly as needed. This guy is 36 takeaway m, so equals k 36 minus m. 1 mark. When the whale is 10 years old, its mass is 20 tons. Again, m equals 20. When t equals 10, find k. All right. What did you get for k?
0.1, but I don't think I put it in the calculator correctly.
0.1.
I
Yep.
got 0.080.
0.080. Maybe that's what you got and you rounded.
Yeah, I rounded it up, yeah.
You can't. It says 3 decimal places. You lose a mark. Be careful. Otherwise, it should have looked something like this. 20 equals 36 minus 35.5 e negative 10k. You're going to subtract 36. You're going to divide by negative 35.5. You're going to log everything. You're going to divide by negative 10. That should give you the answer for k. Are we accepting 0.080, everybody?
Yeah, that's what I got.
Cool. According to this model, what is the limiting mass of the whale? Interesting. Interesting word, because I know a lot of students go, oh, what is limiting? Limiting, I don't get it. Anyone want to give us a clue of the logic of it? Limiting mass.
Is it 30?
Yeah.
Is it 36?
Can you tell us how you got that?
Well, if you look at the dm of a dt, if it is 36, or if it exceeds 36, 36 minus 36 is 0. If it exceeds, it becomes a negative.
Oh, I like the logic. Very smart. The maximum mass can be 36 because of your derivative here. I like it. I'll give that to you. That's it. I like that. The second way would have also been limiting. What's the maximum limit for time? What's your maximum
Infinity.
limit for time?
Infinity.
Infinity. So time approaches infinity. Let's see what the maximum mass it will be. So when time is infinity, infinity times k is still infinity. Negative times infinity would become negative infinity. E to the negative infinity. What's e to the negative infinity? What's happening as it's approaching negative infinity? What's happening to your exponential? It's approaching what?
0.
0. So e to the negative infinity is 0. 0 times anything is 0. So which is 36. Take away 0. So the mass is 36. But Lucas, I liked it. I liked your thinking as well. Rate of growth of the mass can't become a negative. Good job. All right, very good. 2 ways. See? Words that you're not familiar with, just do it and you'll be very surprised. You can get them out. But I like Lucas's method. Maybe that was a lot simpler to start with. But that's probably a second method now. Good work. All right, polynomials. Let's rub this bit out. Okay, let the polynomial x plus 1, x minus 3, q of x plus ax plus b, which we know is because it's dividing by a quadratic, it's going to be linear in term. Where q of x is a polynomial, and it doesn't matter what kind of polynomial this is, it could have been just 1, it could have been x, it could have been x squared minus 5x plus 3. Doesn't really matter. It's just any polynomial. And a and b are real numbers. The polynomial has a factor of x minus 3. What does that mean? That means p of 3 equals to, when p of x is divided by x plus 1, so p of minus 1, the remainder is 8. Find the values of a and b. I think you know what you've got to do. You're going to sub it in. And eventually you should get a simultaneous equation. Good luck. And then find the remainder when it's divided by this. I'll leave it with you guys again for another 2 minutes. Try to see if you can get it out. All right, here we go. Did we get it out? A and B, what'd you get?
A equals minus 2 and B equals 6.
I agree. Anyone have any issues or want me to actually do it? All right.
I got a equals minus 4.
You would have done a mistake somewhere. Your two equations, which should be 3a plus b equals 0 and
I got minus 4 too. Can we go through it? Because
and negative a plus b equals 8.
yeah, and I got.
And then when you minus these, that becomes 4a equals negative 8.
Oh,
equals-
okay.
Oh, I did
Yeah.
this.
You did the same mistake, both of you. That's funny. All right, and then sub it in. Oh, sorry, not sub it in. Oh yeah, sub it into this, and then you should get b equals to 6. Find the remainder when it's divided by x plus 1, x minus 3. Probably shouldn't do it through the whole polynomial division. Obviously, what's the remainder?
Minus 2 plus 6.
Yeah, right. The remainder should be, oops, minus 2x plus 6. That's your remainder. It's already in ax plus b form. They've helped you out. Degree has to be just 1 less, which is right. Okay, that was an easy 3 marks. Any questions? Rates of change. Your favorite. D. Again, I'll leave it with you guys. just to think about, what I might do for myself is just take a screenshot of it so I can, because I know we'll run out of room here. 3 marks. Must have been the other laptop. It's not freezing now. That's all right. There you go. Pen to paper. You gotta work faster, you can't work slow.
Yeah.
You don't have time. Pen, paper, keep going, keep going. Don't listen to me. Just keep going. Okay. No, a little bit longer. A little bit longer. A little bit longer. Okay, let me also start now and see if you guys were going on the right track. A radio transmitter M is situated 6 kilometers. Just before I continue, what are we definitely going to use?
Pythag?
Pythag.
Yeah, Pythag. Like, you definitely know that that's going to just happen. It should be screaming at you. It's situated 6 kilometers. From a straight road. The closest point on the road to the transmitter is S. Okay, a car is traveling away from S, as you can see, at a speed of 100 kilometers per hour. That is a rate. So what rate is that? D what?
dx over dt.
dx over dt. Good job. The change in x with respect to time. Dx on dt. The distance from the car is x, from S, is x, and from the car to M is r. Find an expression in terms of x for dr on dt. All right. Hopefully, if we're used to it, because it sounds like you guys are getting this, dr on dt. dr on times on dt. What letter? Obviously, dx, because that's the whole point of finding it. dx. Do we have dx on dt? Yes, it is 100. Do we have dr on dx? No, I don't have a relationship between r and x. So therefore, I need to create a relationship between r and x. And that's where this guy comes in. Do you have a relationship between r and x? Yes, Pythag. R squared equals 36 plus x squared. R equals square root 36 plus x squared. You don't need to do plus minus because you know r must be positive. It's a distance. dr on dx equals half bracket 36 plus x squared power of negative half times derivative of the inside. You are left with x on the top, half and 2 cancels out, negative half goes in the bottom as square root of 36 plus x squared. Being extension students, we should be able to get to that line. You shouldn't be leaving it as negative half. And then, really, you're done, aren't you? Just, it says in terms of x. You're done. X on root 36 plus x squared times 100. Finished. It was similar to this that I told my Year 12s, this year's Year 12s, to study for their trial HSC. Very similar question, and it was exactly the last one. The good news is I gave it to them the day before, but I can't do that for all of you. So you have to understand, if I say, very important, this one is the case, very similar question that we're going to learn in Year 12, for speed, it's the one that you're very likely going to get. Anyways, any questions? Pretty easy. Pen to paper. Just start. Stop reading too much into it. I guess we'll do this one. Seems easy, but still. At the front of the building, there are 5 garage doors. 2 of the doors are red, 1 is green, 1 blue, 1 orange. How many arrangements are there for the doors? What's our answer straight away? 5 doors, 2 red, 1 green, 1 blue, 1 orange. So 5 factorial on 2 factorial on 2. Because the fact that there's 2 reds, they're the same. How many possible arrangements are there for the colors on the doors if the 2 red doors are next to each other? I think we know what to do with those ones. Isn't it just going to be, if the 2 are next to each other,
4 factorial.
4 factorial. If you said times it by 2, because the 2 reds can change, that's fine, then you have to divide by 2.
Okay.
So you're still going to get 4 factorial. So for whoever was thinking, oh, don't we have to times it by 2 because the 2 reds are going to be next to each other? There's your 4 factorial. Yes, you're right, but because they're exactly red, they're the same, you're going to divide by 2 anyways. Okay. No, that's not for your Year 11. That is Year 12. Oh, there's another 3D trig. Looks fun. Not really. Looks annoying. All right, let me open it up. There it is. Can we all read that? You're trying to find BP. I'll give you guys some clues, I guess. Find triangle, or find in triangle APL, triangle ATP, and triangle TPB. From those triangles, try to work out, no, I won't say it. So find APL. From APL, you'll find something. From APL, then to ATP. And then should work out. I'll give you a clue what to find. In APL, try to find AP. In ATP, try to find TP. And then in TBP, you'll obviously find the one you want, which is BP. That's a little clue. Hopefully some of you are able to get it out. I'll start it another minute or so. Anyone able to get it out?
Me,
Aye?
almost there.
All right, let's try. My turn. In triangle APL. APL. You obviously have tan 20. Tan 20 equals opposite over 1 over adjacent, AP. I told you to try to find AP. So therefore AP equals 1 on tan 20. in triangle ATP. Triangle ATP. Triangle ATP, the one that's elevated. You'll do tan again. Tan 3 equals TP AP. Why did I choose AP? Because obviously I could see it's a common side for the triangle that's at the bottom and for the triangle that's elevated. And then TP is the angle I need to be able to use, to find BP. You're not going to be able to get TB out right now. So I knew it was going to be TP. Where are we? So triangle ATP is equal to, okay, same thing. Tan 3 degrees is equal to opposite TP over adjacent AP. Yep. So therefore TP equals AP times tan 3. But we know what AP is. AP is 1 on tan 20. So the answer is tan 3 on tan 20. Hey, look, we're pretty close. Tan 3 and tan 20. That's TP. You found this guy. Then, of course, you do it again for triangle TPB. Triangle TPB. Tan 30. Oh, I keep writing equals. Tan 30 equals opposite over adjacent, and we're almost there. TP on BP, and therefore BP is equal to TP on tan 30, but TP is tan 3 on tan 20. Tan 30 is 1 on root 3, I'm going to assume. So then you can just bring it up as root 3. So it should become root, I'll just do it slowly, equals TP on divide tan 30, 1 on root 3, and then becomes times by root 3. So root 3, tan 3 on tan 20. I think the hardest thing to that would be where to start. And the fact that it's got all these right angle triangles, you should have started with SOHCAHTOA. The reason why I used tan, it tells me to use it. So it's something maybe that you guys are not used to still, but I hope you start getting used to the fact that it's telling you something, the answer's in front of you. It says 3 degrees, you look at it, you're like, all right, I've got to use tan with 3. It says 20 degrees, you've got to say tan with 20. And then you'll be very surprised. You'll be able to get it out just from this. So this told me what to do. Triangle APL, triangle ATP. This right here. And that skill is hard to develop, but you guys got to get used to that. Find the distance AB. What do we have? There's A and B. Well, obviously, AB equals AP minus BP. That was easy. AP is 1 on tan 20. BP is whatever we just found. Root 3. Tan 3 on tan 20. Something that you guys, again, haven't learned yet, but in the HSC, at least you could get the mark. Look, because in the HSC, you start off at 4 out of 4. All right, the way we mark is you guys will be on a 4 out of 4, and then you lose marks. If in double I it was only worth 1 mark, and you wrote, I mean, clearly you could have at least written this, AB equals AP minus root 3 tan 3, and be like, I don't know how to find AP. We could still give you 1 mark out of 1, because essentially all you didn't know was how to find AP from I. But at least we could have still given you a double I, because if you had found AP, you could have actually got double I out. So it shows to us you actually understand what to do for double I. So we have to give you a mark. So we can't deduct the mark, because it's not like you didn't know what to do. So you guys got to understand the way our marking system works in the HSC is a little bit different to your school ones. It's something you got to develop. Scab as many marks is what you'll hear me say a lot, but anyways. That you can't forget. All right. Let f of x, you can't do that. So you got to do it the otherwise way. That's why it's crossed out for now. You can't do differentiating until next year. Let f of x be this. Show f of x is equals pi on 2. So pretty much in other words, show inverse tan of x plus inverse tan 1 on x equals pi on 2. Can we help each other out? What's our first step? Show inverse tan x plus inverse tan 1 on x equals pi on 2. What should be our first step when we're doing these? Come on. I feel like you should know it. What's your first step?
I feel like I know that.
Say it. Because what are you going to do in your exam? Can't stop. What are you going to do? What do you usually do with inverses?
Alpha.
Change it.
Say it. No, not change it. What did you say?
You let it equal to alpha.
Yeah.
Oh.
Oh, come on. There's no R. You don't have that time. I don't know. It was in the other class. I think someone said it's just going to be. Yeah, it was in the Thursday class. I had instinct. Yeah, those who were there on Thursday heard it has to be your instincts. Your first instinct is right. Like that's what math should be about. You guys shouldn't really be thinking, oh, okay, this is a different question. For inverses, it's always your first step. That's your instinct, and then you just start. I'll leave it with you. Try to see if you can prove it. Let beta be this guy. See if you can prove this plus this. In other words, prove alpha plus beta equals pi on 2. Aya, did you get it out?
Almost.
This is alpha opposite over adjacent. So this is x over 1. Beta opposite over adjacent. Therefore, alpha plus beta must equal to pi on 2. That's alpha opposite over adjacent. That's beta opposite over adjacent. 1 on x. Therefore, alpha plus beta must be 90 degrees for this to add up. Very easy 3 marks compared to some of the other 3 marks we've done. Given that f of x is an odd function, sketch this graph. Yeah, you guys have inverse. But you don't have inverse tan of 1 on x. But then you do know that the y value is always 90 degrees. Oh. Can this be asked or is this meant to be next year? I don't see why not, I guess. I'm going to leave it in there. All right. Well, what do we know? We know the y value of this is always 90 degrees. It's always pi on 2. So we know this plus this is actually another way of just saying draw y equals pi on 2. So show that f of x is this, which is pi on 2. So isn't that just that? y equals pi on 2. The only bit that I'm trying to query now is saying that f of x is an odd function, which just doesn't show that it's an odd function. For it to be an odd function, for it to be an odd function, the only way is for it to also be down here. So give me a second now. Oh, for x is greater than 0. Okay, perfect. Okay, it's y equals to pi on 2 for x greater than 0. Should be like that. And of course, because it's odd, negative pi on 2. So negative pi on 2 also works. Hopefully you guys know odd functions. Odd functions are like this. Let's say if I had something like that, this would be even, this would be odd. You get this, you flip it again about this axis. That would be an odd function. This would be an even, odd. So, same thing. If I know it's in the first quadrant, it's got to go to the third quadrant. Why did I draw open circles? Because x can't equal to 0. X is not equal to 0. X is greater than 0. So it can't be equal to 0. All right. I guess that's allowed. I don't see why not, actually. I'm going to say that's allowed. That would probably be a bit more of an advanced extension question. So, because you guys are usually only, drawing that or drawing that, whereas what they've done here, they've told you that that actually becomes 90 degrees. And then so that's easy to draw. You saw how I draw it. But the problem was it's actually telling you it's also an odd function. So you're gonna understand what an odd function does. And then open circles because it's not equal to. So good question. I would like to see that in your exams. I would put it in. Okay. Because I can't see many getting it right. So therefore I would put it in. A, do this one. And then we'll do the binomial question. I probably need some more room myself. I'm just gonna, 1 mark. It's probably towards the end of the paper. Because I don't think it's going to be technically 1 mark worth of working out. But anyways, that's how these work.
I think I got it.
It wasn't really worth 1 mark, right? Well, probably what, 4 or 5 lines?
Yeah.
Yeah, like I said, it looks like probably towards the end of the paper. Maybe this would be, I'm guessing question 6, question 7 of the old paper, which means band 6. But anyways, I cos A cos B minus sine A sine B. Oh, actually,
Is it plus or
it's
Isn't it
plus.
plus?
Yeah, yeah. Well, straight away plus, yeah. Maybe quicker. That's left-hand side. Right-hand side, I think. Why would you want to make the left-hand side into right-hand side? You might as well just start with the right-hand side because I can see the expansion is cos A cos B plus cos A cos B times tan A tan B. Cos A cos B times sine A on cos A times sine B on cos B, and then just cross out because you already know the answer and you're done. Cos A cos B plus sine A sine B. If you really wanted to go from left hand side to right hand side, obviously you would have to change sine A sine B to this big monster. You have to know to do that, which no one just does, right? You'll probably start with your right hand side at that point. Okay. Well, actually, maybe not too bad, but still. I did it probably quicker than most of you guys, but you would have done a little bit slower. Should still work out very, very much the same. Double I. Suppose B is between 0 and 90 degrees, and A is between B and 180. So B is between 0 and 90 degrees. Nothing too fancy, but then A is obviously somewhere between B to 180 degrees, where B is between 0 and 90. So A could be anywhere between 0 to 180, but it can't be equal to 90 degrees or 0 degrees or 180 degrees. Deduce that if tan A times tan B equals -1, then A minus B equals pi on 2. If tan A tan B equals -1, then A, okay, well, what do you guys straight away think I'm going to say? This guy equals -1, what am I going to do? Don't just look at double I. What was the point of just doing all this math? Just look, what am I going to say to do? Sub it in. If you guys are not thinking like that, why are you isolating? Sub this into here. 1 minus 1, 0. 0 times anything is 0. I get cos A minus B equals 0. Any questions? No? What's inverse cos of 0? Inverse cos of 0 should give you 90 degrees. Very easy. Done. The only thing is that you should say, it depends. Look, it's 1 mark. It's a tricky one. Yeah, because it only happens. It says deduce, which just means get it out. Would they have accepted it? That's something I've got to look at the marking criteria to find out. So it just depends with that 1 mark if they would have accepted that or if they actually wanted you guys to use the definition as well. All right, well, only one way to find out. That's fine. Let's look at the marking criteria for that. 2008. Are we still up to 2008? Yeah.
Are we doing 2010 now?
Are we? Let me have a look. Yeah, you're right. It's 2010. I'm behind. 2010. Maths extension 1. Well, I need the paper so I can find the question. Probably somewhere here. Yep, question 6A. I thought so. Marking guidelines, notes from the marking center. Marking guidelines. Yep. You see here, how it says correct solution compared to correct answer. There's a difference between the two. When we mark, correct solution means your working out is correct. Correct answer means we don't really care about the working out, it's just the answer. See, this one says correct answer. We don't really care about how you've done it, as long as you got the right answer out. But anyways, I'm gonna go question 6A. Correct deduction. Yep. You will not get a full mark if it's done like that. So, A minus B equals to pi on 2. And then we know that obviously cos is positive. So what would you do with that? You would usually have 360 plus or minus this as well, right? You would do 360 minus theta, or in other words, it's 360 plus minus 90 degrees. Do we understand? Because we could have added 360 and subtracted 360. Whatever I've always taught you. Add as many, subtract as many. So we would need to see that. Then you'll need to see but. B is between 0 and 90 degrees. Let's just keep it as 90. And B is less than A is less than 180 degrees. So then we know we're not going to use the 360 plus or the 360 minus. In fact, it's 360n. It's any multiple of 360. So let me write that again. Let me just go 360n. So, one second. It's 360n, right? Because we can add 2 360s, 360, 3 360s, 4 360s, 20 360s. All right, so 360n plus minus 90 degrees. But because B has to be between 0 and 90 and A has to be between B and 180, technically n would equal to 0. And then you're just going to get, because it can't be negative 90, as it's got to be between 0 and 90, therefore A minus B must equal to 90 degrees. Pi on 2. We actually needed to see, probably the most important line, I think, would have been this line here. We needed to see that. We needed to see that you can add as many and subtract as many 360s to a 90 degree angle because of the definition of what I've taught you, you know, or you can just keep going, keep rotating, but then because you're restricted, you just get A minus B equals pi on 2. So, correct deduction for that one. You couldn't just say A minus B equals pi on 2. And that's why I had to check that. I didn't think it would be worth a mark by just doing that. Oh, okay. Any questions? That's a tricky one. That's a definition. Again, but you saw it was question 6. So, all right. Binomial theorem states this, something that we already know. Let's try to see if we can finish this off. The binomial theorem states this. Show this. Obviously, what do we do with these ones by now? 1. The x equal to 1. 1 plus 1 is 2. 2 to the n gives you n choose 0 plus n choose 1 plus n choose 2 plus all the way to n choose n, which is exactly what this is. K is 0, n choose 0, plus, this guy means sum. Don't forget that. Sum. So n choose 0 plus n choose 1 plus n choose 2 plus all the way up to n. N choose n. Easy. Hence or otherwise find the value of this. Oh, very easy. Anyone see what's happening with that one? Compare it. I thought it would be harder. What's happening?
It's
What?
n, isn't
N is
it? 100.
100. So the answer is 2 to the power of n,
N
which is
to the power of 100.
2 to the power of 100. That was an easy one, Mark. See, sometimes binomial, I think what you can learn from this is you don't know what topic will be hard in your exam. So like those who are stressing about binomial, look at that. In a 2010 paper, that was the easiest question. And maybe the hardest would have been, let's call the rates of change. Maybe this year, the hardest question was binomial and rates of change was easy. Whatever, you can't predict. But there you go. That wasn't too hard at all. I'll probably leave it there. I can send you guys these. All I did is just compile the 3-unit prelim papers, HSC papers to prelim questions. If you want that, I'll actually just send it across now. Discard. If you want the solutions, they'll be online. If you're staying back,